Every episode so far quietly handed the model a clean, ready dataset. But real data is a mess. Features on wildly different scales, missing values, text categories that models can't read. And the steps to fix all that have to be applied very carefully, or you will accidentally cheat and fool yourself. Scikit-Learn's elegant answer is the pipeline. Chain every step into a single object that always does the right thing in the right order. Picture a raw table. One column is age from 0 to 100, another is income in the tens of thousands, a third is a city name, just text. A few cells are simply empty. No model can consume this directly. Every one of those issues has to be handled first. So we line up pre-processing steps, fill in the missing values, that's imputation. Put the numbers on a common scale, that's the standard scaler we keep using. And turn each category into numbers the model can read, that's encoding. Only after all of that is the data truly model ready. But here's the trap that catches almost everyone: data leakage. If you scale or impute using the whole data set before you split, then information from your test set has quietly leaked into training. Your score looks great, and it's a lie. The rule is ironclad: every transform must learn its settings from the training data only. A pipeline enforces that rule for you automatically. You chain your pre-processing steps and your model into one object, call fit once, and it learns each step in order on the training data alone. Call predict and it replays those exact same transforms before the model sees anything. No leakage, no forgotten steps ever. And when different columns need different treatment, a column transformer handles it. Scale the numeric columns over here, one hot encode the categorical columns over there, all in parallel, then hand the combined result onward to the model. It's the clean way to wrangle messy mixed tables. The payoff is huge. Your whole workflow becomes one tidy object. It cross-validates correctly because the pre-processing is refit inside every fold. It's trivial to save and deploy, and you never again accidentally scale your test data with training statistics. This is how real Scikit-Learn code is actually written. The pieces: simple imputer, standard scaler, and one hot encoder for the steps, column transformer to route columns, and pipeline to chain it all to a model. It's a bit longer, so 2 pages. Let's write it. Here's the program, 2 pages, every line visible. It looks busier than usual, but it's really just assembling a little assembly line. Page 1 builds the pre-processing. Page 2 chains it to a model and runs it. Let's go. The imports. This time it's mostly tools, not models. Simple imputer for missing values, standard scaler and one hot encoder for the transforms, column transformer and pipeline to wire them together, plus logistic regression as our final estimator, and the usual split and accuracy. We name our columns: 2 numeric columns, age and income, and 1 categorical column, city. We'll treat these 2 groups completely differently, so we keep their names in separate lists. Now the numeric branch has its own little pipeline. First a simple imputer to fill any gaps with the median, then a standard scaler to put it on a common scale. 2 steps chained just for the number columns. That's the end of page 1. On page 2, the categorical branch, a single one hot encoder that turns each city name into a set of 0-1 columns the model can actually use. Now we have a recipe for each kind of column. The column transformer ties the 2 branches together. Apply the numeric pipeline to the numeric columns, the encoder to the categorical column. and produces one clean combined feature matrix. And finally, the full pipeline, the preprocessor followed by logistic regression as one single object. We call fit on the raw training data. It preprocesses and trains in one go. Then predict and score with every transform correctly applied and zero leakage. And that's preprocessing and pipelines, the real glue of a machine learning project. One object in the right order, no leakage, ready to deploy. Next time, the question every pipeline eventually raises: how do we actually know it's any good? That's model evaluation and cross validation.